So, hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am again back with power factor controlling system. So, as you can see here on this model, I will use a fuzzy logic controller, and fuzzy logic controller will uh, turn on and off capacitor as per the running power factor. So, uh, as you are well aware about it, I have already uploaded the two video related to the power factor correction. This is the first video. This is the first video in which I have used a stepwise capacitor, and as it is a stage-wise capacitor. You need to manually on so that it will improve the power factor. Whenever the second one is a thyristor based control, in which by turning on and off the thyristor, we can set the reactive power amount of reactive power that have to be fed inside the system to maintain the power factor. So I suggest that please go through both video and then switch over this video, so you will get to know about everything very well. So let's start our simulation, and let's start. I will explain the simulation step by step. So as you can see here right now, this is a fuzzy logic controller block, and I need to add the first logic inside it. So how I can add it? So I need to write first of all fuzzy here. So as I write fuzzy, it will open the block, fuzzy logic block. So it may take some time. So we need to wait here. Okay, so you can see this is a fuzzy logic block, and I have already designed my fuzzy logic block. So I just open it from my library. So I need to import it. Okay, so how can I import from my files? I have downloaded it in my files. So you can see here, this is my fuzzy logic block, and I need to open it. And once it is open, you can see this is a fuzzy logic that I have designed, and that I have to first of all export inside the workspace. Okay, so I have exported in the workspace. What it means that I have added it, and once it is added, I need to press on these explanatory symbols, and then I have to fix it. So yes, it is fixed, and it has now logic, and the error is gone. And if you want the what is the fuzzy logic inputs and output, I can show you. As per our power factor, I have set inputs and output, and as per that, the fuzzy logic block is there. This is the input block, and this is the output block. Okay, and according to the power factor, it will generate a output. So what actually means that in the previous video, we need to manually turning on and off the capacitor bank, but in this it will totally done by the fuzzy logic controllers, and also giving us output. And as per the output, we need to it will automatically turn on this capacitor block. So just I set the load at minimal condition. So right now the load is minimal condition, and we will check how many capacitors bank will get turned on to maintain actual power factor. And at this condition, we have considered to maintain a power factor more than 0.95, and we are in most cases getting the power factor nearly 0.98. So which is working very satisfactorily as per the industrial standards. So I just start the simulation. The load is only this load is right now in the on condition. So we'll check how the capacitor will come to the picture. Okay, it is taking compiling time, so we need to wait right now. Okay, so this is the error because I have saved the file in the wrong direction. So I just need to change the direction of it. So once it is compiled completed, I will do it, and I will run the model once again. You may also facing such issue when you are trying to do the simulation over the MATLAB. So make sure you are aware about such errors. So this is the fuzzy logic output. Whenever input is this, we are getting this output. So you can just check, you can just change the scale, and according to that you will see the outputs are continuously changing. You can see, you can you can switch this red line according to your requirement, and as per that the output is changing. Okay, so yes, first of all I need to change the directory. So this is a directory, it is in the bin, so I cannot run that in. So I just run in the program files, and I am go back towards simulation and just run the model. Okay, so as you can see, only one load is there. So we will check how many capacitor will come to the picture and what will be the running power factor after the capacitor come to the picture. Okay, to start the compiling. So as you can see here, only one load is there right now, and that's why only one capacitor bank is on. You can see it is on, and remaining are off, 000. And you can see power factor is 0.9851, which we have maintained. So which is very satisfactorily. So as I increase the load, what will happen? We will check. As you can see, this is the switch, and by this switch, when turning on this switch, the load will increase. The load is increased. This is one, and the power factor is changed, number of capacitor output is also changed. So it takes some time to stabilize, so it is increase decrease, and once it is completed, you can see 2 is output. It means that 2 is on and remaining 2 is off. So, and what is the power factor? Power factor is 0.9817, which is again very satisfactory factorily. And again I increase the load and will check power factor is increase or decrease. As you can see, as I increase the load, power factor is reduced, and that's why the numbers of capacitor on is also increased. And once it is stabilized, it is a 3. So you can see 3 load is on and power factor is also maintained. Okay, and again I turning on the 4 input, and you can see it is a 4, and yes, power factor is maintained. So this is how the fuzzy logic controller giving us output, and as per the output we need to turning on and off our numbers of capacitor bank. Here are manual switches are also provided, but it is just for the your convenience purpose. You can just turning on and off whenever the simulation is running. If you don't want, just make sure this all the switches are in the off condition. Now we have step by step increase our load. Now we will step by step decrease our load. So I just decrease first load and will check whether the capacitor is, what is the power factor? 0.9138. So even though if your load is low and the capacitor is high, capacitor all the capacitor bank is high, at that condition also your power factor is reduced. So you need to maintain your power factor 0.98, and that's why finally this, whenever I turn off this load, you can see this capacitor bank is turning off, and remaining 3 is in the on condition because 3 load is in the on condition, and we are getting 3 as output. Right now again I reduce this capacitor, not a capacitor, industrial load. So you can see again this reducer. It takes some time to stabilize because it's just turning on and off and checking the power factor like this way. That's why. Okay, so once it is stabilized, you are getting 2 and only 2 is on, remaining 2 is off. Now again I just turning off this and we'll check whether the power factor is maintained or not. It's drastically increased. 4 means all on. So it automatically turning on and off all the capacitor banks and checking whether it come to the stabilized condition or not, like this way. Okay, so you can say it takes some time, but after that it will be stabilized. Okay, and finally only one capacitor bank is there and only one load is there. So this is how the fuzzy logic controller accurately measure the power factor and turning on and turning off the capacitor bank. So I just giving you some overview. This is a calculation of the power factor, and this is the input supply. We will use the 33 kV as the input voltage source, and this is a all industrial load which is highly loaded load, like a industrial motors are there, which is the inductive load, and that's why the power factor is drastically reduced, and that's why capacitor bank is required. And all the industry have to maintain the power factor more than 0.95, otherwise they have to pay the penalty also. And if you want to check the power factor graph, you can see from here. Yes, so this is our power factor graph, and there is slide ups and downs due to turning on and off the capacitor, but finally we are getting the power factor nearly 0.98 for all the condition. You can see for all the condition we are getting power factor nearly 90. Yes, there is switching, but it is very low, and if you want you can set the limit of this xy plane. And yes, if you set the limit like a minimum to 0, so you can see it will be looking very lower, and if you reduce it like a -5, then it will be reduced much more. Okay, so due to scaling you are facing like this is a very high, but it is just a point 0.8. So this is how all the times there is slight variation, and then capacitor, then the power factor come to constant value, and which is nearly 0.98. So this is how satisfactorily the system is working and maintaining the power factor greater than 0.98. So thank you very much for watching this video. If you have still any query, just comment it. I will definitely reply. If you want this simulation and this fuzzy logic file, that is available in my description box. You can connect with me through my email ID or through my WhatsApp number. That is also given in the description box. Thank you very much for watching this video. And for any type of such project, such MATLAB project, electronics, electrical project, you can connect with me through my email ID or through my WhatsApp chat that is given in the description box. Thank you.